Hello and welcome back to another episode of Whether or Not. I'm your host, Luke Snyder, joined alongside our forecaster, Jonathan Domow. Now, Jonathan, we've got break coming up. Are we going to be seeing any sort of travel impacts as students begin to leave campus heading into the weekend?
Well, it's really a matter of what day you're leaving and what time. It also depends on what direction you're moving in. We're looking at the most significant impact will be probably Friday afternoon, but I'll take a look at that more in my forecast.
Awesome. Thank you so much for that, Jonathan. We'll hear about his forecast in just a few moments, but up first, here's Nature in the News.
Earlier this week, California was hit by a powerful atmospheric river that slammed the state with heavy rain, strong winds, and flash flooding and landslides. The storm funneled a concentrated ribbon of Pacific moisture straight into the west coast, dropping several inches of rain in a short time and triggering mudslides in areas already weakened by wildfire burn scars. Mountain communities in the Sierra Nevada picked up a significant amount of snowfall, while low-lying areas from Los Angeles to the Bay Area dealt with swollen rivers, road closures, and widespread power outages. Emergency crews carried out multiple water rescues as neighborhoods struggled with runoff, and officials warned that saturated ground will keep the risk of mudslides and debris flows elevated even after the heaviest rain moves out. It is a sharp reminder that these atmospheric river events, once thought of as an occasional winter storm, are becoming more intense and more disruptive as California swings between long droughts and bursts of extreme rainfall.
Skies in North America flared last week as another round of auroras lit up the night. This follows other spectacular shows in October and May of 2024. But are the northern lights becoming more common? The dazzling light show caused by the aurora borealis is from the interaction of solar energy with Earth's magnetic field. High-energy particles bombard Earth. Our magnetic field guards us and transforms the energy into visible light. This magnetic field is stronger towards the poles, but if enough energy enters the Earth, that light spills closer to the equator. One factor leading to recent activity is the 11-year cycle that solar storms follow. Currently, we are at the tail end of this cycle's peak activity. This leads to more sunspots and magnetic explosions, therefore, more energetic strikes hitting the Earth. The National Oceanic and Atmospheric Administration's Space Weather Prediction Center ranks these geomagnetic storms on a scale from 1 to 5. The most extreme category, a G5 storm, normally occurs a few times a decade. Last May's storm was a G5, whereas last week's storm was a G4. Even as the sun reached its peak last year, solar activity is expected to remain above average until early 2026, and hopefully we'll be able to witness a few more beautiful northern lights.
In the 2020s, guessing that Pennsylvania will have a below-average winter in terms of snowfall is a pretty safe bet. A new analysis shows that much of the Commonwealth has been trending towards weaker and warmer winters, with snowfall running below average for the past 5 years. Even traditional snowbelts in the Laurel Highlands and the northern tier have seen noticeable declines, while cities like Philadelphia, Pittsburgh, and even Erie have recorded some of their lowest early season snowfall totals in recent memory. Trends highlight higher temperatures, fewer strong coastal storms conducive to snow, and a pattern that continues to favor rain over flakes. This winter could still deliver pockets of cold if the polar vortex dips south, but overall the odds lean slightly below average for seasonal snowfall across most of Pennsylvania. For those snow lovers hoping for those classic long-lasting winter scenes, the trend is pointing towards fewer of them and more seasons defined by temperature swings and slushy storms.
In Utqiagvik, Alaska, the sun just set for the last time this year. On Tuesday, our nation's northernmost town had the sun set at 1:36 p.m., and it isn't expected to rise again until January 22nd of next year. The city of Utqiagvik is 330 miles north of the Arctic Circle, which means that for roughly 2 months of the year, the sun stays below the horizon, leading to a polar night. This is a result of the Earth's orbital tilt. Earth is tilted 23.5 degrees on its axis, and it leans the northern hemisphere either towards or away from the sun. If you're within 23.5 degrees of the North Pole, that area is blocked from seeing sunlight during winter solstice due to the region's constant tilt away from the sun. The exact opposite happens in the northern hemisphere's summer solstice. That same zone is constantly tilting toward the sun, thus never allowing nighttime to set in. Even during the typical night hours, land within 23.5 degrees of the North Pole never fully swings into Earth's shadow, causing the sun to shine for 24 hours of the day.
Friday is shaping up to be a big travel day for many Penn State students headed home for the break, and coincidentally, it'll be potentially the most impactful travel day depending on where you're traveling. Let's take a look at the fronts map, and you'll notice there is abundant rain chances all over the place, but depending on where you are and where you're going, that's where you'll see either heavy or light rain. If you're traveling within Pennsylvania, you're looking at mostly drizzle, not very impactful to your commute, but if you're headed anywhere north or south or even west, that's where we're going to see the heavier rain, all thanks to a low pressure system to the north that is bringing in heavier rain, and this stationary front attached to another low pressure system way off to the west that is really going to increase the intensity of the rain. But for Saturday, when we're looking at the Penn State home football game kicking off at 7 p.m., well, we're under the spell of some high pressure, and that's going to clear us out, but also bring the temperatures down to a nice cool day on Saturday. However, as that high pressure moves out, we'll be looking at above average conditions, clear conditions as well on Sunday, as we are in a big block of warm air. Now, for Friday, we're going to be seeing that rain mostly at the end of the day. Afternoon, 51 degrees, and by Friday night, will be a chilly but dry 38 degrees, and Saturday the rain will have fully tapered off. Will be 47 degrees, mostly sunny, and we'll even dip below freezing Saturday night, 27 degrees, mostly clear, before we come back up to be above average for this time of year, 50 degrees on Sunday and mostly sunny. If you've ever wondered how AI can impact forecasting, well, Rebecca Newell has got you covered with a feature on AI forecasting.
Forecasting the weather always comes with a little uncertainty. It's a mix of science, technology, and human discernment. Traditional forecasts are built on physics-based numerical weather prediction models, or NWPs, which can sometimes miss the mark, especially when it comes to rapidly changing weather events. Now, a generation of artificial intelligence forecasting models is emerging, offering meteorologists another tool to improve their accuracy. Rather than replacing human forecasters or traditional models, AI has the potential to emphasize them.
Traditional numerical weather prediction then uses computer code that encodes the laws of physics, things like conservation of mass, energy, and momentum, to make a forecast. What's different about AI models is we instead use AI to do pattern matching. We learn how to take an atmospheric state at one time and match that to an atmospheric state, say 6 hours in the future. So in that case, we're not using the laws of physics directly, but learning them from lots of examples.
AI NWP models' unique development through thousands of case studies make them a nifty tool for large-scale weather events.
AI models are very good at pattern matching and pattern recognition. So they can do a good job at identifying a pattern for an extreme weather event a number of days in the future, maybe the track of a tropical cyclone or the location of a northeast winter storm. What they are yet struggling with is to predict the small-scale features.
Because small-scale phenomena like thunderstorms have so many nuances to their development, AI NWP cannot currently predict their formation far in advance. But there is research being done attempting to amend this shortcoming.
So we are currently building an AI model for convection initiation. In other words, imagine there's a big sporting event in State College, and we want to know, will it rain in the next hour? So what our AI model does is takes a look at satellite imagery and predicts which clouds might just pass the stadium by versus develop into a thunderstorm that might necessitate action to prevent harm to people and property. AI models are very good at matching patterns. So if you give it many thousands of examples of clouds and tell it which of these developed into a thunderstorm and which did not, it then becomes really good at applying it to a new cloud it hasn't seen before and able to make an accurate prediction.
Graybush's AI research model analyzes satellite imagery to predict which clouds might pass overhead harmlessly and which could turn into heavy rain or severe thunderstorms. Short-term forecasting is largely based on current satellite and radar signatures. Before anything appears on radar, an AI model could tip forecasters off to potential severe weather. AI modeling could be used to increase accuracy and shorten the lead time to warn for severe weather events across the country. When a tornado or flash flood threat appears, every minute counts. With AI, forecasters might detect dangerous situations minutes earlier, giving communities extra time to take proper safety precautions.
We've had some good success stories where the AI model has predicted that clouds would develop into a thunderstorm, whereas the most state-of-the-art models for numerical weather prediction failed to predict this storm to develop. So in a particular case, clouds are building over State College, If one looked at the state-of-the-art National Weather Service model, the HRRR, which is usually very good in these situations, you would find that this model showed that there would not be any showers in the next hour. But using the AI model, we were able to see that the clouds were building and growing and showed signs of developing in a thunderstorm. And sure enough, within the next 10-15 minutes, a thunderstorm did develop over State College that would not have been predicted well with traditional methods. In the future, AI modelings will probably be used to increase the accuracy as well as shorten the lead time to help us warn for severe weather events.
Overall, AI models have the potential to be a wonderful new tool for weather forecasters, but they still have their limitations. It is unlikely that they will entirely replace traditional physics-based models, and they certainly won't replace human forecasters. AI has its own strengths that can be used alongside regular models to upgrade current forecasting practices. Through a combination of AI and traditional models, forecasters will have increased options to iron out uncertainty in their forecasts. For Whether or Not, I'm Rebecca Newell.
This coming Thursday is Thanksgiving, and along with it is the busiest travel week of the year here in the United States. But before we get to that, let's recap the weekend. We're going to kick things off 51 degrees with some rain, mostly at the latter half of the day on Friday, before we transition to mostly sunny on kickoff day for Penn State football, 47 degrees. Keep an eye on that low temperature. We'll be below freezing Saturday night at 27, but we'll rebound and have an above average day on Sunday, 50 degrees, mostly sunny to start off next week. Now, here's a look at the extended forecast. In Turkey Day travel troubles, well, the short answer is no. We're going to kick things off on Monday, above average, 53 degrees, mostly sunny here, a few clouds in the sky, but nice and dry. Now, the biggest chance for rain we're going to see is on Tuesday, where we approach average a little bit closer, 47 degrees, but the rain will be mostly an all-day event here in central Pennsylvania. But the rain chances will begin to taper off late Tuesday into early morning on Wednesday. So if you have any travel plans on Wednesday in the middle or the end of the day, you'll be looking nice and dry here. Temperatures well above average again, 54 degrees. Now, for the actual day of Thanksgiving, we'll be directly at average, 45 degrees, but we'll be nice and dry. There'll be more sun in the sky than clouds here. And in time for Black Friday, below average temperatures, 42 degrees. But if you have any plans to do some shopping, take advantage of those Black Friday deals, well, you'll be looking at mostly cloudy, but again, it'll be nice and dry for the Black Friday holiday shopping. And stay tuned to get the answer to the Weather Whiz quiz question.
If you guessed letter D, 23.4 inches, you would be correct, and that happened here in State College in 1995. Now, Jonathan, I don't think we're going to be seeing any snowfall totals like that anytime soon here.
Unfortunately not. For the month of November, we are sitting at 1.9 inches, which is unfortunately nowhere near 23.4, and with what we're looking at in the upcoming forecast, we won't be approaching it at all this month.
Exactly. So for our snow lovers out there, not the best going to be seeing here for the month of November. But for anyone with travel impacts, definitely be more on the brighter side. Well, thank you for your forecast this week, Jonathan. We're going to be seeing you all again in 2 weeks with our regularly scheduled program, but next week is actually going to be our holiday show. We're going to see a little bit more behind the scenes from the cast, as well as a couple features alongside as well. But thank you all so much again for joining us this week, and we'll see you again next week.